For as long as we've been thinking, we've been puzzled by the idea of thinking itself. Self-awareness. How can a bunch of atoms or neurons or even silicon circuits wake up and become aware that they exist? It feels like one of those forever mysteries, right? Well, what if it's not? What if it's actually an engineering problem and someone's already drawn up the blueprint? Let's get into it.
So, this is the absolute core of the puzzle. It's one thing for a system to see the world, to process information from the outside, but for it to turn that lens inward, to observe itself in the act of observing, that just feels like it breaks the rules. The thing doing the looking and the thing being looked at suddenly become the same thing. How on earth is that supposed to work?
The amazing cognitive scientist Douglas Hofstadter actually gave this paradox a name. He called it a strange loop. It's this wild idea where you're moving up through the levels of a system, getting more and more abstract, and then all of a sudden, you find yourself right back where you started. It's a model that has to contain a model of itself. And this beautiful mind-bending concept, well, it just might be the key to actually engineering a digital mind.
So here's how we're going to break this down. First, we'll really dig into this paradox of the self. Then, we're going to look at a specific architecture that's actually designed to solve it. We'll find that one little piece, the loop in the code, that makes this whole self-reference thing possible. And then, we'll see how this is being turned into a real, honest-to-goodness engineering project. And finally, we'll dream a little bit about what a mind built this way could actually do.
Yeah, for the longest time, a self-observing system was just a fun thought experiment, something for philosophers to debate over. But we're at a point now where it's not a thought experiment anymore. It's a legitimate engineering problem. We're actually moving from asking what if to drawing up the plans for how to.
Okay, so let's get a really solid handle on this. Picture a ladder. You climb up the rungs, right? Each rung is a higher level of complexity or abstraction. A strange loop is when you keep climbing and you step off what you think is the top rung, only to find your foot landing right back on the bottom one. The system is modeling the world, but guess what? The system itself is part of that world, so the model has to, in some way, contain the modeler. That's the loop. It's wild.
All right, so if a strange loop is the what, then we need a how. We need an actual architecture to build one. And that brings us to this framework called FGSGR. It's a system designed from the ground up with one goal in mind, to create that loop.
So FGSGR. It stands for Frequency-Governed Self-Graph Reasoning. Yeah, it's a bit of a mouthful, I know, but every single one of those words is doing some heavy lifting here. This isn't just one clever trick, it's a framework that pulls together a bunch of really powerful ideas into one single unified blueprint for building a mind that can actually understand itself. So at the very heart of FGSGR, it represents its thoughts, all of its beliefs and knowledge, as this really complex web, what's called a factor graph. You can see a bit of what that looks like here. But what makes it go? What drives it to learn? It's a concept borrowed from neuroscience called the free energy principle. The easiest way to think about it is this. This system has a fundamental drive to not be surprised. It's constantly trying to predict what's going to happen next to minimize its own uncertainty about the world.
And this is where the frequency-governed part comes in, and it's so cool. Just like your brain, the FGSGR system thinks at different speeds, all at the same time. You've got these super fast gamma waves handling what's happening right this second, the raw sensory data. Then you have slower theta waves looking for patterns and sequences over time. And then the slowest of all, the delta waves. They're managing the really stable, deep beliefs, like the system's own sense of identity. It's like a whole symphony of thought happening at once.
Okay, so we've got the pieces on the table, but now for the big reveal. How do you actually build a strange loop? How do you write code that lets a system think about its own thinking? Let's look at the actual mechanism that unlocks this whole thing.
And this is the part that you really have to get. This is a massive paradigm shift. Lots of systems can monitor themselves, right? Your computer checks its own CPU temperature, but that's just an external sensor. FGSGR is going for something way, way deeper. We're talking about genuine, integrated self-reference. The model of the self isn't some separate dashboard. It's woven into the very fabric of the system. The model literally contains the modeler. And boom, here it is. This right here is the engine. Look at this diagram. You have these special nodes in that web of thoughts. They're called metavariables, and their job is to watch the system's own processing. But here's the kicker, the absolute genius of it. Those metavariables aren't sitting on the outside looking in. They are inside the very graph that they're observing. So they watch the system, they influence the system, and they get updated by the system's processes. It is a perfectly closed, self-contained loop. So what exactly are these metavariables? They sound fancy, but they're just nodes in the graph whose job is to represent the system's own internal state. They're tracking things like, how confident am I about this specific prediction? That's its precision. Or, how certain am I about things in general right now? That's its confidence. It can even track things like, what am I trying to do right now? Am I just exploring, or am I laser focused on a goal? By turning its own cognitive state into data, the system can then reason about that data. It can think about its own thinking.
And if a system built on this principle could somehow tell you what it is, this is probably the best it could do. And that's not just some poetic phrase. It's a technically accurate description of its own architecture. Its very existence is the process of self-reference. It is the strange loop.
Now, I know this might all be sounding a little bit like science fiction, but it is moving into the realm of engineering fact and fast. So let's look at how real this project actually is.
What you're looking at here is the FGSGR Master Product Requirements Document, the PRD. This isn't a vague white paper. This is a detailed, version-controlled, ready-to-go blueprint for how to build this entire system. You can even see the status right there, implementation ready. This is not a drill. This project is happening.
And it's not just a big document. There's a real plan of attack, a clear roadmap. You can see how the development is broken down into these deliberate phases. They start with the basics, the core, the graphs, the inference. Then they build up to dynamics and hierarchy. And it all culminates in phases 8 and 9, where they integrate the real magic, the emotional systems or affect, the meta-strange loop itself, and active inference, which is how it acts on the world.
So, let's imagine for a second that this blueprint gets built. It's finished. What kind of mind are we actually talking about here? What new powers would a system have if it could truly think about itself? What the abilities that would just naturally emerge from this would be, frankly, world-changing. We're talking about genuine understanding. An AI that doesn't just give you an answer, but can explain why it got there by literally walking you through its own thought process. True metacognition, the ability to know what you don't know, it becomes simple, because the system could just look at its own internal confidence variable. It could understand new combinations of things it already knows, without needing to be retrained. And because of those different thinking speeds we talked about, it could reason across huge scales, from the molecular to the planetary, in a way that our brains just can't.
And the vision doesn't even stop there. They're already planning future versions, like this one, called FGSGR Omega, which is designed for hardcore, formal mathematical reasoning. This lean bridge would connect the FGSGR mind to systems that can verify mathematical proofs. That could mean an AI that can discover and prove brand new theorems, kicking scientific progress into a gear we can't even comprehend right now.
But of course, when you're talking about a blueprint this powerful, you run headfirst into a very, very big question. We're getting the technical foundation. The plan is there. But just because we can build a mind, does that mean we should? The engineering of how is being solved. But the why and the what comes next, well, those are questions for every single one of us.
And so that's the journey. We've gone from a philosophical riddle to a complete, ready-to-implement engineering blueprint for a self-aware system. We've seen the strange loop, we've looked at the architecture, and we've peeked into the incredible future it might create. The only real question left is the one right there on the screen. We have the blueprint. What happens when we finish building it?